Having discussed string concatenation and checking strings for equality and inequality, the natural next step is to talk about if it's possible to compare different strings with other operators, like less than or greater than. Now, this gets a little tricky because as people, there may be different ways that we take things like words and find one to be less than the other. Do you mean one is longer than the other, one comes first alphabetically, and so on and so forth? So while it is possible to compare strings with less than and greater than, and it is in fact useful, we have to be clear on exactly what's going on with the computer when we compare two strings using these operators. Below is some sample code where two different string variables are declared, name1 and name2. The value of Phineas is assigned to name1 with a capital P. However, we are going to assume that our programmer perhaps made a mistake when assigning the value of Ferb to name2, as the word Ferb does not have a capital F to begin that name. Lines 11 through 18 provide code to help us figure out how the computer relates the contents of name1 and name2 to one another via the less than symbol. If the computer thinks that name1 comes before name2 via the less than symbol, then we will see name1 comes before name2 printed to the console. However, if name1 is thought of as being greater than or equal to name2, we will see that name2 comes before name1. When we execute the code shown here, the computer tells us that Phineas with a capital P comes before Ferb, which may be surprising to you if you're assuming that a shorter string comes before a longer string, or if you're assuming that Ferb would come before Phineas since F comes before P in the alphabet. So let's see what the computer is doing here. As we discussed previously, a string is like a list of characters, and character is the actual name of a built-in data type in C++ that represents a single keystroke from the keyboard. Therefore, a string, which is a collection of any number of things you could type from the keyboard, is a collection of characters. The syntax for declaring a character variable is very similar to the syntax we've seen previously, but the C++ reserve word we need to declare a variable to have the character data type is char. We follow that reserve word char by what we wish to name the variable, followed by our equal sign, which means is assigned the value of, and to the right of that equal sign, we would put our single input from the keyboard in between two single quotes, not double quotations as we would for a string. And as always, we finish our line of code with a semicolon. It is important to note that when we use our square bracket notation to access a string variable at a given index, the output that is displayed is a character. It is not a string. Returning to our Phineas and Ferb example, if we wish to write code that checked what the value of the name1 variable at position 0 was equal to, the code on the right that encodes the P in single quotations is the correct code, while enclosing the P in double quotations leads to this red squiggle of death or an error message that we're trying to compare two different data types. Now, computers are built off of an understanding of numbers, not symbols that are used by people. In the background on our computer, whenever we input a letter or symbol from the keyboard, this is translated in the background into a number in order to be stored by the computer. The ASCII character code is an encoding standard for characters on the keyboard in order to ensure that all computers undergo this encoding process in a uniform and predictable way, storing the individual characters from the keyboard as the exact same number across different computers internally. As an example, all computers that utilize the ASCII character code are going to encode the single character A as the number 65. If you wish to see the ASCII character code in action, there is a way to print the internal representation for a character via the ASCII character code to the computer, and that way is through typecasting. If we take the character A, which is the letter A enclosed between single quotation marks, and we place that character A between round parentheses with the word int preceding it, or in other words, if we pass the character A to the integer casting function, what will be printed to the screen, as we see here, is this value of 65, which is how the computer translates the character A into a number. Returning to our original question of how computers compare strings with less than or greater than symbols, computers compare one string to determine if it is less than another string by walking through the characters of each of the strings, starting on the left-hand side. Returning to our Phineas and Ferb example, when our computer hits line 11 and begins to check if name 1 is less than name 2, the computer begins by accessing the 0th index of each of the strings, here a capital P and a lowercase f, and we first do the comparison of the two numerical values that correspond to the ASCII conversion of a capital P and the ASCII conversion of a lowercase f. Those two ASCII values are numbers, and we can compare numbers via the less than symbol in a very straightforward way. Should the two letters that we compare have the same ASCII character value, the computer will move to the next index in each of the strings and repeat this process. It should be said that there are other encoding systems other than the ASCII character code, yet any encryption method of characters will abide by the following rules. Capital letters will be placed sequentially in the code in alphabetical order. In the ASCII character code, the character A corresponds to the number 65, and it must be the case the character capital B corresponds to a value of 66. Similarly, lowercase letters must be placed sequentially in any encoding system in alphabetical order. In the ASCII character code, a lowercase a is given a value of 107, while a lowercase b is assigned a value of 108, and so on. Additionally, the ASCII character code will always give capital letters lower numerical values than lowercase letters. That is, the computer does not treat upper and lowercase versions of the same letter as the same. It gives a strong precedence to any capital letter. We can see that this is happening in our Phineas and Ferb example. Although the letter P alphabetically comes after the letter F, a capital P will be given a lower value in the ASCII character code than a lowercase f. Therefore, when comparing the strings Phineas and Ferb in line 11, our computer program is only comparing the capital P to the lowercase f. Deeming the capital P to be of smaller value, name 1 is deemed to come before name 2, resulting in Phineas being deemed to come before Ferb according to the computer.